Welcome to my video on complex numbers in polar form. In the previous videos, we've talked about complex numbers and just represented them in the rectangular form, which would be just z is equal to a plus bi, or we could do x plus iy, however you want to do it, as long as there's two constants and then a I symbol in there, either -1, square root of -1. So that's what we've looked at in the past. So now we can also represent a complex number in what we call polar form. This has certain advantages, especially in engineering when we're dealing with voltages and currents. And so what I'm going to do in this video is show you how to convert from rectangular to polar and go over what the polar coordinate system means. So just as we saw in the rectangular coordinates, we have the imaginary axis and the real axis. And we have our point Z, and it's got a certain magnitude, R, and we make an angle theta. In rectangular coordinates, we just give this a point. It would be like X, Y would be that point right there for Z. But now we're going to do it in terms of a magnitude, R, and an angle theta. So this is the way we would write our imaginary number now. Z is equal to R, and then the angle of theta. So that's what it's going to look like in polar form. So now let's do a conversion. What we want to do is we want to figure out how to convert these rectangular complex numbers into a polar form. So first of all, let's just draw our basic. Here is our polar coordinate, or our complex plane. The vertical axis is going to be the imaginary portion. The horizontal axis is the real portion of the number. Here's going to be Z. That's our basic complex number. And we've seen so far that this distance out there called the magnitude is R. And it's going to make an angle theta with the real axis. Now we can do a little trigonometry here to generate some relationships. We know that the projection of R on the y-axis, or on the imaginary axis, we'll call that y, and the projection of R on the real axis, x, we'll call that distance right here. So there's our distances. Now what we know is the real portion of z is equal to x, the imaginary portion of z is equal to y. We're going to define that. And so from trigonometry, we know that x is equal to r cosine theta, just from the basic definition of the cosine. And we know that y is equal to r sine theta, also from the definition of what a sine of an angle means. And then the tangent of theta is just equal to the imaginary part of z divided by the real part of z. So that's just going to be y over x. So there we have some relationships. So what we can say is that z, which is equal to r theta in the polar form, is just going to be r cosine theta, that's the real part, plus I sine theta. So we've basically now just taken this polar form over here, and this is going to be our conversion down here between the two systems. Next, we want to do an example. We want to convert the complex number z is equal to 4 plus 3i to polar form. So first of all, let's work on the magnitude. And we know that the magnitude of r is just the square root of the real and imaginary part squared. So in this case, that's going to be x is equal to 4 squared plus 3 squared, which is equal to 16 plus 9 is equal to the square root of 25. That's equal to 5. So the magnitude of our polar coordinate complex number is 5. Now let's do the angle. And we know that the tangent of theta is equal to y over x. What's the imaginary part over the real part? So in this case, that's going to be 3 over 4, which is just equal to 0.075. That's just 3/4. So we know tan theta is equal to the tan inverse, now taking the tan inverse of both sides, of 0.075. What we're going to do is we're going to use our Desmos calculator to do this calculation. So this is the Desmos scientific calculator. And what I want to do first of all is I want to open up the more functions because I need to get into the tan inverse function. And then I'm going to type in, go back to the main, type in 0.75, close the parentheses, and that's going to give us 36.87, and it's going to be in the degrees. Notice the degrees is highlighted. Now if we want to convert it to radians, or 0.643 radians. So that's going to be the answer for our angle. So back into our example here. So theta now is equal to 36.8 degrees, or 0.643 radians. So there's our numbers that we need. We know the magnitude and the angle. So next, let's just do a plot of this and see what it looks like. Let's get into our standard imaginary plane here, the real part. The vertical axis is the imaginary part. Now we know the angle is less than 45 degrees, so it's going to be something like that maybe. And then the r is equal to 5, so that's the magnitude of it. The angle, theta, is equal to 36.8. So now if we wanted to kind of do a rough approximation of what that is, now that's roughly a ratio of 4 to 3. I could have done a better graph and got it more exact, but I think you get the idea. Hopefully you do. Hope you learned a little bit about complex numbers in polar form and doing a conversion. If you did, give me a like, thumbs up, subscribe to my channel. Thank you for watching.